es Becka.
Mi nombre es Pablo.
My name's Sam.
Thanks for watching us on DPS TV. So today we're going to talk a little bit more about quadratics. What specifically we're going to get into is the quadratic formula. If you cut to my screen, we'll talk a little bit briefly about what we have been going over. First we looked at forms of a quadratic equation, and then we looked at a couple methods. So there are videos if you are interested of converting quadratics to different forms. So we looked at converting a quadratic from the Xbox factoring method, and we also looked at converting a quadratic to vertex form by completing the square. Another method, possibly, to convert a quadratic to factored form, which is that one that you see on the bottom there, is by using the quadratic formula. I'm not saying that it is the best way to do it, but it is a way to do it. I have had students in the past who just preferred this way. And I also think the quadratic formula is worth talking about because it is also a way that we can solve quadratics. So first we'll talk about solving quadratics, and then we'll apply that to actually using it to convert the quadratic into factored form, since that's what we've been talking about. So let's look at a specific quadratic equation. And again, quadratics are equations where we have our variable to the power of 2. You can see that this one is a quadratic one. What I would tell you is that I have seen students try to solve this a lot of different ways. For example, they've tried to get this x by itself by adding 4 to both sides. And then when they do that, they realize that they've got an x over here. And so they're trying to square root and get x by itself, but there are 2 x's. So when you have a quadratic with two terms with x in it, one as an x squared term and one is just an x, you cannot solve by isolating the variable. Don't try it. A lot of my students try to do it all the time, and you just either end up stuck or you end up doing some incorrect algebra. And you know what? Let me take that back. It's not that you cannot solve it. It's that the algebra to solve it is very complicated, which is why we have the quadratic formula. So the quadratic formula was derived by somebody who took the general form of a quadratic that looks like this. We've talked about that before. And they isolated x. They did all of the complicated algebra steps to do that and got this. And so what we can do is we can use that to as a shortcut and not have to do all of those complicated algebraic steps to isolate x. So we use this almost as a shortcut here. So one of the requirements to using the quadratic formula is that your equation must be in standard form to start with. So ax squared plus bx plus c. So you may need to be doing some algebraic manipulating to get it there. The other requirement is that it must equal 0, or we must also understand that our y is equal to 0. So just a quick example is if you had something in the form of y equals, this would help us find our x-intercepts because our y is equal to 0 at our x-intercepts. Oh, I didn't mean to undo that. Let's go back there. Okay, good. So let's look at an example here of how this has actually worked or applied. We'll go back to that equation that I showed you to begin with. X squared minus 4 equals negative 3x. And as I mentioned before, the equation must be in standard form and also equal to 0. It is not. And so what we can do is a little bit of algebraic manipulation to get it there. So we're going to add 3x to both sides of our equation. And what you may notice on the left side of our equation, 3x is not a like term with either of the terms that I have there already. So I don't have to add it to either of those. It kind of gets tacked to the end there. However, I'm going to, when I rewrite it, I'm going to write that plus 3x in the middle there, because if I do that, then it's in kind of the proper order. We've got our x squared term first, we've got our x term second, and our negative 4 term third. So then the second step in this is to determine what our a, b, and c are. And let me go back to the equation up top. You can see that a is the coefficient in front of x squared, b is our coefficient in front of x, and c is our constant. So, looking at our equation, our coefficient in front of x squared, well, it looks like there is none. So if there is none, we know that it's a 1. It's understood that it's a 1. So our a is going to be 1. Our b, or the coefficient in front of x, is 3. And our c, or our constant, is -4. One thing to keep in mind is don't forget signs. If you have a minus, that counts as a negative. So then from there, we're going to just plug it into this formula over here. And I'm going to erase this equation here so that I've got some room to write. So I have x is equal to negative b. So if you look back to my b is 3. So we're going to write -3. And then we do plus or minus the square root of b squared. So b is 3. Minus 4 times a, which my a was 1, times c, which is -4. And this is going to be all over 2 times a, which is 1 again. Now, just a quick little calculator tip. If you end up having a negative number for your b, so if your b was negative, over here when you put it in the calculator, you want to make sure that you throw parentheses around that number when you're typing it into a graphing calculator. And this is a big deal because this will mess up your whole entire answer. And I will tell you that anytime my students have an issue with it and they didn't get a correct answer, I would put money on the fact that they probably forgot the parentheses around that number there. So get in the habit of putting parentheses around it because you need them in the calculator. It'll throw you off otherwise. Another calculator tip is, and this is how I do it anyways, and I suggest to my students, is everything under the square root, I just throw that all into the calculator all at once. Please don't try to throw this entire thing into the calculator. You would need a lot of parentheses and placed in the correct places to be able to type that all in the calculator all at once and for it to calculate for you. So do this in parts. My suggestion is do everything under the square root first. So we would do our 3 squared minus the 4 times 1 times -4. And what we would end up getting is 25, I believe. So we'll rewrite our equation. Let's find my black marker. We'll rewrite our equation, our equation as this. So we just did that part there. And over 2 times 1, which is just 2. So I kind of do those two parts all at once. Then from there, we can actually do our square root. And the reason why I suggest to do the square root second rather than to do it all at once is because if this number ends up negative, you'll just end up with an error. And I really like my students to see that it's a negative number and that's why they're getting an error. So I always suggest underneath do this first and then do square root. So we'll do our square root of 25, which is 5, all over 2. And then here's where we're going to bust into two solutions. We know that, that most times, and I'll just draw a quick sketch, most parabolas have 2 x-intercepts or 2 solutions. Not always, because you can have some different cases where you only have 1 x-intercept, or you can even get into a situation where you have no x-intercepts like that. But most will have 2. So we have to consider the positive and the negative square root. So we bust into our 2 different solutions. One of them is going to be -3 plus 5 divided by 2. The other would be -3 minus 5 divided by 2. And then just continuing this to simplify it, our division is our very last step. -3 plus 5 is going to give us 2 divided by 2, which gives us 1 as one of our solutions. And then on the bottom, we have -3 minus 5, which is -8 divided by 2, which gives us -4 as our second solution. So solving, going back to this particular equation here, solving it, we end up getting x is equal to 1 and x is equal to -4. Now, quickly, I did mention that I would show you how to use this to convert a quadratic. So let's just say that our equation was this, very similar to what we started with. Y equals x squared plus 3x minus 4. These numbers here are your roots. And if you think about what factored form looks like, and maybe I'll just go back to this here. You look at what factored form looks like, see on the bottom here, this R1 is one of your roots, and this R2 is another one of your roots. So what we did when we just solved with that quadratic formula is I found R1 and R2. So putting that into the equation, I have this. I have A, I'm just going to remind you what it is first, R2. A, I actually know already from my standard form. Look back up here. Here's my A. I already know my A. So that's just a 1, and a 1 we don't really have to write. 1 times anything is just itself. Then I have x minus R1, so x minus 1, which was my first root. And then x minus -4, and minus -4 ends up being plus 4. So there is maybe not the quickest and easiest way to convert an equation to factored form, but if you've got roots that are decimals, this is actually probably your best bet. So quadratic formula is one of those big staples in math classrooms that you really are just going to have to know because it's used so much and it's so useful. It can solve equations, it can find roots, it can find zeros, it can find x-intercepts, it can help you convert equations, it can help you do a lot of things. So it's really definitely something that you should know, and hopefully that helped explain it a little bit better.